Okay, Assalamualaikum and good morning. How are you? As promised, I will discuss further on our tutorial question of section 1.2. Okay, before we continue with concentrations, I would like to have a recap on empirical formula. However, I think question 9 in your handout is quite obvious, similar to what you have learned at school. So um, we'll proceed with question 10. Yeah. Okay. Now it says a complete combustion of a hydrocarbon forms 1.1 gram of CO2 and 0.45 gram of H2O. Okay, now, what do we understand by the word combustion? Combustion means something is burned, right? Something is burned, therefore, it has a reaction with H2O. Hydrocarbon means the compound contains only carbon and hydrogen. So we'll have it maybe in the form of CXHY. CXHY reacts with oxygen. Yeah, normally it is burned in excess oxygen, and the products are, yeah, it says the products are 1.1 gram of CO2 and 0.45 gram of H2O. Now we have CO2 plus H2O. Okay, what are the information given in the question? We have mass of CO2, which is 1.1 gram, and mass of H2O, that is 0.45 gram. Okay, we want to know our X and Y here. Yeah, X and Y. Now, what can we see from the equation? Can we say that all of carbon in CO2 comes from the carbon in the hydrocarbon? Yes, right? Because in the other reactant, there's only oxygen. So definitely all of carbon here comes from the hydrocarbon. Therefore, we can say that the number of mole of carbon here equals to the number of mole of carbon here, yeah, in the hydrocarbon itself. So let's calculate. Now, we know the mass, so basically, we can calculate the number of mole. 1.10 gram of carbon dioxide. What's the molar mass? Yeah, mass over molar mass. The molar mass is 44 gram per mole. And that will give you, okay, you can calculate the value yourself. By right, you should get it to be around 0.025. Okay, now let's calculate the number of mole of H2O. Why do we need the number of mole of H2O? Because, okay, similarly, can we say that the hydrogen here comes totally from the hydrogen in the hydrocarbon? Yes, right? Because there's only one source. Now, again, we have 0.45 gram mass over molar mass. The molar mass of H2O is 18 gram per mole. And you should get the value to be around 0.0025. Oh, sorry, 0.025 mole. This one as well is 0.025 mole. But this is NCO2 and this is NH2O. We don't want H2O, we don't want CO2, but instead we want carbon in this case, and in the other case we want hydrogen. So now, how do we relate? Remember, we relate different components or different species by using mole. Now, in 1 mole of CO2, there is 1 mole of carbon. So in this case, since we have 0.025 mole of CO2, what is the number of mole of carbon? And if you calculate the number of mole of carbon, or just C, equals to 0.025 times 1 over 1, and that gives you 0.025. Similarly, okay, for hydrogen, 1 mole of H2O contains, what's the number of mole of hydrogen? Look at the formula. How many hydrogen? Correct. We have 2 moles of hydrogen. In this case, we have 0.025 mole of H2O. Therefore, what's the number of mole of hydrogen? And when you calculate, the answer should be 0.025 times 2 over 1. Show the calculation, yeah? Therefore, finally, you will get it to be 0.05 mole of hydrogen. Right? Are we okay? Now, knowing the number of mole, knowing the number of mole, you can calculate the empirical formula. Yeah? Now, okay, I think you can proceed with that. Okay, let's proceed with question 11, where you need to know 5 types of concentrations. Yeah, and the first thing that you should do, because you don't have only one, you have 5, you need to be clear of the formula of each. Now, for a concentration to exist, the solution, okay, say that this is the solution, everything is called solution, and what makes up solution? It is solute plus solvent. Now, solute is for example, NaCl. When it is dissolved in water, water is the solvent. Okay, now, what's the formula for molarity? Molarity is the number of mole of solute. The unit is mole over the volume of solution, and it must be in liter or decimeter cube. Same thing. Okay, this one here is molality. Okay, molality. How is it different from molarity? For molality, the formula is N of solute, also in mole, over mass of solvent. And the unit is kilogram. Must be kilogram for solvent. Mole fraction, the symbol for mole fraction is X. So if we are referring to the mole fraction of A, that means the formula is the number of mole of A over the total number of mole in the solution. And next, we have percentage by mass. What is the formula? It is mass of solute, gram normally, over mass of solution, also in the same unit, times 100, and percentage by volume, similarly, is volume of solute, normally in milliliter, over volume of solution. Alright, we'll stop here and we'll continue in the next video.